Last time we ended with this problem where you were dividing a polynomial by another, and you split the numerator into two polynomials, one which divides evenly and then a remainder term, and that lets you perform the division with a remainder. There's actually an algorithm. There's a step-by-step process that you can use to do the same thing, which is sometimes convenient, although it is going to be super important that you understand this structure later on for other reasons. But let me show you the algorithm. Let's actually go ahead and scoot down here. And then we can pop back up in a minute. All right, so this was the problem we were doing. Let's write it this way, sort of elementary school style. So we've got, let me do this down a little bit. Okay, so we have x squared plus 4x plus 5 as the thing that we're dividing. And x minus 2 is what we're dividing it by. And here's how the algorithm works. You want to think something times x is going to equal x squared. So what times x is x squared? And the answer is clearly x. And so then what you do is you multiply x by both pieces here. So x times x is x squared, and x times negative 2 is negative 2x. Then you subtract. So x minus x squared gives us 0, because that's how we chose our number here, so that would happen. And then 4x minus 2x. Be careful. 4x minus 2x gives us 6x. And now you repeat the process again. Let's delete, or let's erase this for a minute. Okay, so now I want to know what number here times x gives us 6x. And the answer is 6. So 6 times x gives us 6x. And then 6 times negative 2 gives us negative 12. And so again, we subtract. And what are we subtracting? So 6x minus 6x gives us 0. And then we're subtracting the constant term from this constant term. So 5 minus 12 gives us 17. And that's the remainder. The way you know it's the remainder is if you wanted to continue carrying on the process, you'd ask, what times x gives us 17? And the answer would have to be 17 divided by x, because that's the only thing that would have the x cancel to give you 17. But now we no longer have a polynomial up here because we don't have non-zero powers of x. This is something divided by x. So once you reach your constant term down here, that's the remainder. And so now you can write the answer. You know that this original problem, this divided by that, is equal to x plus 6 with a remainder of 17. But what it means to have a remainder of 17 is that left over you have 17x minus 2. Okay, so let's go back up again. You can see the whole thing. Whoa, okay. So you can see us two different ways of doing the same process. We ended in both cases with x plus 6 plus 17 over x minus 2. It's just that here it was sort of a mechanical process. So this is what you do if you just care about the answer and you don't want to think too hard. This sort of shows you more why it makes sense that you would write your remainder as a rational expression off to the right-hand side here. I think this makes sense of the process where, just like a number, your polynomial can be broken into pieces, one of which is factorable. Why don't you try this one on your own? Here I've got a cubic, which shows another advantage of the mechanical process. The mechanical process extends very cleanly to handle higher degree polynomials. So we'd rewrite this as x cubed plus 2x squared minus x plus 1, and you're dividing by x minus 4. So start the whole process again, starting from the question, what times x is x cubed? And write your final answer as a polynomial plus a remainder term divided by x minus 4. Okay, give it a shot. All right, let's do it. So here we've got x squared times x is x cubed. And that makes intuitive sense because if I'm dividing a third power of x by a first power of x, I know that the result should probably be a second power of x. so far so good. So we've got x cubed, then x squared minus 4 times minus 4 is negative 4x squared. And now we'll subtract, so those become 0. 2x squared minus negative 4x squared becomes 6x squared. So now I want to know what times x is 6x squared, and the answer is 6x. So 6x times x is 6x squared. 6x times negative 4 is negative 24x. And so now I'll subtract. So hold on. So this becomes 0, and then I'm subtracting the linear terms here. So negative x minus 24x. So that's the same thing as like adding 24x. So that's going to be 23x. Okay, so now what up here times x gives us 23x? The answer is 23. So 23 times x is 23x's. 23 times negative 4. All right, so 20, 40, 60, 80, and then 3 times 4 is 12. So that's 92. So that would be minus 92. And now I'll subtract. So I've got 23x minus 23x is 0. 1 plus 92 is 93. So that's the remainder, is 93. And so now I can rewrite my original equation. I know that x cubed plus 2x squared minus x plus 1 divided by x minus 4 is equal to this answer, x squared plus 6x plus 23, with a remainder of 93 divided by x minus 4. Just to show you that we could do the same thing by factoring, if you're curious, you can watch. So we know that we want to break this polynomial into two parts, one of which is factorable. So we know we're going to have an x minus 4 factor, times something, and then we're going to have a little term out here, which is the remainder, which is going to help us adjust to make sure that we end up with the plus 1. Okay, so what's going to go in here? So this is just like we did before, only you have to think a little harder because we're going to end up having 3 terms here, as you'll see. So I know that I need some term here that's going to end up as x cubed. So clearly that's going to be x squared. Okay, so now I know I need a term that's going to end up as 2x squared. And so you might think, okay, let's make this 2x, because that way we'll have x times 2x gives us the 2x squared. The problem is, later on, we're subtracting 4x squared. Imagine multiplying this out. We've got the x cubed plus 2x squared plus some number of x's minus 4x squared. So it's like whatever... So I want x here, but it's like however many x's we have here, we need to we're going to subtract 4x squareds. So it's like some number of x squareds minus 4x squared is 2. So that means this has to be 6, because 6x squared minus 4x squared is going to give us the 2x squared. Okay, so I think that makes sense. And now we have a term out here that's going to give us our x. So because this is negative x, again, you might think that this is negative 1, because then we'll have x cubed plus 6x squared minus x, and that gives us the minus x here. But remember, we also have an x term coming from negative 4 plus 6x. So this is giving us negative 24x. So whatever number I write here has to combine with negative 24x to equal negative 1. So the only thing that combines with negative 24 to equal negative 1 is 23. So let's make sure it makes sense. So we've got x cubed, and then we've got 6x squareds, and then here we've got 23x's, but then later on we'll subtract 24x's to give us the negative x we need. Okay, so when all is said and done, the constant that we end up here with is negative 4 times 23, which is negative 92. But we know that we need to end up with a constant of positive 1. So let's add 93 on the outside to combine with the negative 92 to equal positive 1. So you can see that and this is exactly what we did with the long division. We end up with two terms. We end up with this term and the remainder term. Here, these divide out, and we end up with the x squared plus 6x plus 23. And then the remainder term gives us 93 divided by x minus 4. So you can still do it by factoring, but you have to think a little bit more carefully about how all the things combine to give you the coefficients that you need. Whereas the advantage of a mechanical process is you don't have to think to do it. You can just crank it out and it's done.